Currently, the organs that are being printed in labs are only molds of the target organ that can then be seeded with the appropriate cells. However, without any stimulus provided by blood flow and other tissue interactions, the printed organ will not be functional. The challenge is to print an organ that contains support scaffolds, blood vessels that deliver nutrients and signal molecules to the organ, and multiple control functions that can respond to internal and external stimuli. The organs on chips method involves placing cells into elaborate but still fairly simple models of the target organ, which is approximately the size of a microscope slide. The purpose is to provide a unique perspective for research into organ function and disease, as well as for applications such as toxicity tests for drug trials. Organs on chips are made by layering a photosensitive material onto silicone, and then an ultraviolet light is used to etch a pattern of grooves that is used to guide the production of a 3D network of hollow tubes. Then the tubes are seeded with cells of the desired types and attached to pumps and an external fluid source that allows the scientists to mimic blood flow and deliver nutrients and environmental signals to the model. The other approach that researchers are taking is to provide an environment that will foster the ability for cells to self-assemble, in the hope that they will mimic actual organ development and therefore give insights into that process. The soft scaffolds seeded with cells result in organs that look much more like the actual target organ. Scientists are using microfabrication to develop models that closely mimics blood flow in tissues. These are being used to find better ways to predict injuries to blood vessels that a trial drug may cause. Scientists are also using 3D printers to create intricate tissue scaffolds and are trying to incorporate blood flow into a model organ. The eventual goal is to find a way to print fully functioning organs that will replace the need for an organ transplant. Research into 3D printing organs has applications in biology, chemistry, and biomedical engineering. Scientists need to implement their understanding of all three disciplines in order to tackle the current issues with 3D printing functional organs. Thank you so much for watching!
Created using Powtoon.